Okay, we have this question in physics. The diagram below shows a magnet being pushed into the coil connected to an ammeter. So we have this coil or the solenoid which is connected to the ammeter, and the magnet is being pushed into the coil. The question is, explain why an ammeter records electric current. When the magnet is pushed into the coil, changing magnetic flux is created around the coil. Okay? And the changing magnetic flux created around the coil induces EMF, induces electromotive force, induces total potential difference into the coil. The induced electromotive force drives electric current throughout the circuit. Okay? So on part A, we are saying when the magnet is pushed into the coil, changing magnetic flux is created around the coil. Okay? For example, if we have this coil and we have this magnet being pushed into the coil, we are saying changing magnetic flux is created around the coil. Okay? Like this. So the changing magnetic flux, we are saying changing magnetic flux created around the coil induces electromotive force. Okay, we are saying changing magnetic flux induces electromotive force or total potential difference. Okay, into the coil. Into the coil. The induced electromotive force drives induced electric current throughout the circuit. Induced electromotive force drives induced electric current. Throughout the circuit. So I say the created changing magnetic flux induces total potential difference into the coil, and this induced electromotive force or total potential difference drives induced electric current throughout the circuit. And when this happens, we are saying there is a flow of electric current in the circuit. And because an ammeter is a device which is used to measure electric current, it will record or register electric current as it flows throughout the circuit. Part B, we have this question. What magnetic poles are on end X and end Y of the coil? When we push the north pole of the magnet into the coil, it creates what we call repulsive force. Repulsive force, so that there is that repulsion And when there is repulsion, it means that the coil, the end X of the coil possesses similar polarity of the magnet being pushed into the coil. So now that we are pushing the north pole of the magnet into the coil, and we are saying that creates repulsive force, and X becomes the north pole. Okay, north pole, and Y becomes the south pole. Just an addition, when we withdraw the magnet out of the solenoid or the coil, it will create what we call attractive force. If we were withdrawing the magnet, would have and X would have become south pole. And now that we are pushing, remember when we are pushing into the coil, it creates repulsive force. And when we are withdrawing the magnet, it creates what we call attractive force, meaning the two acquire different polarities. So, just in conclusion, in relation to our question, we are saying Y becomes